Hello, my name is Thanasis Rikakis, and I am the Dean of the USC Iovine Young Academy. This is a recording of a presentation I gave in the summer of 2024 at the Erich Bloch Symposium on Materials Design and Innovation. I would like to thank Professor Krishna Rajan, the Materials Design and Innovation Department, and the University of Buffalo for their very kind invitation to this very exciting and timely meeting. My talk will propose that the complexity of a sustainable 21st century society requires new innovation processes that can be realized by socio-technical creatives that are cultivated through challenge-based reflective learning. The agenda of this workshop highlights that the complexity of current challenges requires diverse, interconnected knowledge. Industry and academia have been talking about the urgent need for knowledge connectivity for over 50 years. But as we can see from the agenda of this meeting, such interconnectivity still remains elusive. Humans should not have a problem with connecting diverse knowledge to address complexity. In engineering, we talk endlessly about the complexity of smart systems that integrate diverse sensors, actuators, multi-stream processing, and real-time interaction and learning. However, this is exactly what all humans do through embodied everyday learning. And in embodied multimodal learning, the quantitative and the qualitative, the physical and the intellectual, the explicit and the tacit are actually fully and continuously integrated. There is also a lot of talk lately about the complexity of immersive and spatial computing, but human beings have excelled for centuries in connecting their everyday embodied learning to immersion in complex and rewarding environments. So, if human beings are so good at integrating diverse knowledge to deal with the complexity of the world, why is knowledge connectivity so elusive in our educational system? Why is the prevalent system of education based on disciplinary silos? To answer this question, we need to go back a bit and remember that the original motivation of disciplinary education system was the analytic understanding of the world. And there was good reason for that at the time, since we were trying to move societal structures for systems of belief to systems of logical thinking. But human beings are actors. We generate meaning by doing things. So as soon as people started understanding well the different pieces of the world, they started making artifacts that leverage that knowledge. Like artifacts that moved production of goods from manual to mechanized. But as the level of our making gets more complicated and the scale of our making gets bigger, the effect of our making exits the disciplinary silo in which we learn to make. And our making begins to contribute to the complexity of the real world. In this process, however, we tend to forget that disciplinary understanding and making works primarily within the constraints of the complicated, not the complex. Here is a simple presentation of the differences between the complicated and the complex, based on the work of Felt and Hathaway in the startup community and by Devek in engineering systems, but also influenced by work of other people like Scott Page. When dealing with a complicated system, as we see on the left, that is knowable, predictable, controllable, replicable, and mechanical, we require domain expertise and we require precision, which means that disciplinary preparation can well address the complicated. But when dealing with a complex system that we see on the right, that is not fully knowable, has limited predictability, is not controllable but is guidable, is not well defined and therefore cannot be fully replicable, and is evolutionary and emergent, things change. Within a complex system, we need to accept that precision is not achievable. We cannot aim for a precise and replicable solution or a perfect product. Those don't exist in complexity. We need to aim for developing processes that support the iterative improvement of human performance in complexity. There is a key philosophical point here, of course. The people that perform well in complexity are the people who accept and coexist with complexity, rather than try to solve complexity or simplify it. Complexity experts cannot be cultivated through the disciplinary education system, since disciplinary education aims to cultivate people who can solve constrained, complicated problems with precision. Addressing the complex requires new types of learning that leverages the unique abilities for human embodied performance in the wild and iterative learning in complexity. Reflective learning is ideal for cultivating complexity experts. We need to, of course, clarify that the complex contains complicated components. So the complexity experts cultivated through reflective learning will need to collaborate with disciplinary experts that can handle the complicated components with precision. But the overall specs for dealing with complexity need to be developed by reflective learning experts. We know by now that when we ask disciplinary experts to deal with a complex challenge, they usually end up modifying the complex challenge to make it fit within the confines of a complicated challenge, to make it have a clean, replicable solution. Over 100 years ago, pragmatist philosophers like John Dewey proposed that reflective thinking is the way to deal with the complexity of the human experience without losing the ability to deal with domain-specific knowledge. Reflective thinking is cultivated through the continuous movement between the complex human experience and the domain-specific components of that experience. This constant movement trains both deduction and induction as interconnected abstract abilities. Interconnected deduction and induction supports the cultivation of complex reflection. Reflection about the complex human experience, its components, the relations of these components to each other and to the experience, and the relation of this experience to other experiences. Reflection leads to iteration, thus cultivating further reflection. Reflective learning brings the process of learning into the foreground. Reflective learning highlights that humans use different learning processes to deal with different needs. As Michael Poliani points out, humans deal with the complexity and uncertainty of the real-world experiences through custom combinations of tacit, implicit, and explicit knowledge. And as Herbert Simon points out, when dealing with the real-time complexity of the world, humans don't try and produce optimal, replicable, and controllable solutions. Instead, humans aim for satisfying decisions and actions in complexity that allow them to learn through the complex interaction and bring that learning into the next iteration. The Iovine Young Academy, or IYA for short, has developed the challenge-based reflective learning framework, or as we call it for short, the CBRL. The CBRL aims to apply reflective learning to the cultivation of socio-technical creatives that can engage 21st century complexity and continuous innovation. The CBRL promotes for learners the continuous movement between the full complexity of current challenges and their components. The IYA education focuses primarily on product and process innovation challenges that emerge at the intersection of the human experience with technology. Complex challenges that contain different combinations of areas of expertise of the YIA, like design strategy, extended reality, product innovation, interactive computing, business of innovation, and transformative AI. The complex socio-technical challenges utilized in the IYA education are real-world challenges that are provided by industry and community partners, as well as driven by students and faculty. Students, faculty, and industry partners work together to learn how to spot challenges and generate creative responses in complex and often underexplored territories. To accomplish this, students work in and out, back and forth, and through a series of stages for innovation. Discern. Collaborate with diverse stakeholders to understand the problem spaces you're working within. Prompt. Write a challenge prompt, an ambitious and open-ended question that serves as the project's North Star. Dig deeper in areas related to your prompt. Prototype. Learn and explore the challenge through active making. Feedback. Access insights from a diverse network of stakeholders. Plan to improve and move on to next steps. The outcomes of this learning are drastically different from the artifacts and processes generated through disciplinary training. For example, the IYA has partnered with the Information Sciences Institute at USC to research and teach transformative AI. The learning and research in transformative AI starts through participatory design with diverse stakeholders to discern a complex need for societal transformation and define how the societal need and AI can intersect to drive transformation. Then, and only then, do we derive the AI design specs and we prototype the desired AI and society interaction. Not just the AI, we prototype the full interaction. Then we test with stakeholders and redesign. And we only translate when the integrative transformation design specs have been met. The design methodology differences between reflective learning and disciplinary education are fairly clear here. In reflective learning, we don't start from the AI and try to fit it to society. We do it the other way around, from the societal need to the AI and society interaction. This example also illustrates the reasoning behind the IYA areas of expertise shown in an earlier slide. To tackle complex transformative AI challenges requires knowledge in transformative AI, but also knowledge in interactive computing, product and process innovation, and design strategy. Here is another challenge we worked on with Dell. Even though the hardware innovation is part of the challenge, the drivers of the challenge are needs of workers in hybrid and remote work environments. And again, in this example, although we aim to leverage extended reality technologies within the challenge drivers are custom needs of pediatric care. As students at the Iovine Young Academy experiment with different challenges, they discover the challenges they want to focus on. Students can then decide which IYA courses, as well as which USC-wide courses, they need to take to improve their ability to reflect on their chosen challenges. Students thus become the drivers of their own lifelong reflective learning. All IYA courses use the challenge-based learning methodology. Here are 4 first-year IYA courses that all anchor their teaching in current socio-technical challenges. But as each course digs deeper, their prompts and prototypes focus on the specifics of each course, business and traffic computing, design, so forth. But each course always returns to place these specifics within the original challenge. Since the courses use the same CBRL methodology, the students can see how core components of each course influence and shape complex socio-technical challenges. In turn, this cultivates reflective learning. I want to take you through some examples of some other recent challenges we worked on with industry to indicate that CBRL can apply across all kinds of different types of complex challenges. For example, what might the future of the internet look like? A challenge we worked on with Google. Or, how might emerging technologies and other societal trends reimagine experiences of care in the future? We worked on this with Ernst Young. Or, how might we find jobs in the future? We worked on this with ZipRecruiter. Or, how might trends like blockchain technology, pop-up retail experiences, and the circular economy impact infant and toddler toys, something we worked on with Fisher-Price? Or, how might we anticipate the future challenges and desires of educators? What does the student experience look like in the future? A challenge we worked on with Apple. As students go through these highly diverse challenges, their imagination is ignited and they begin to imagine their own student ventures. Here's an example. The company handle that focuses on 15-minute or less delivery of snacks by students for students was created by 2 IYA undergraduate students who graduated in May of 2024. The company is now in over 6 campuses nationwide and has raised more than $5 million. The students started the idea together in their first year of study, and as they iterated through the idea and matured the venture, they had to learn diverse skills across different domains so they can make their venture work. For example, they had to learn about real estate, but they only had to learn the components of real estate knowledge that were necessary for making their venture work. This is highly contextualized, domain-specific learning. CBRL facilitates many types of student ventures as it cultivates for students their individualized creativity, like Rari Capital, started by a couple of sophomores at IYA and recently merged with Fay Protocol to create a player with $2 billion liquidity. Or the augmented reality startup Mira, developed by 2 IYA students and purchased in 2023 by Apple. Or the sustainability startup Ren, that has already raised significant amounts of credits for offsetting individual and company carbon footprint. Or the startup Gen C, created by 2 IYA students who also recently graduated. The startup is increasing access to resources and investment to emerging Gen Z women leaders. And since this is a materials workshop, we do need to finish with a materials design and innovation challenge. Almost a year ago, our research professor Malcolm Jones helped connect the IYA to the amazing work happening at Solar Impact and the Beehive. The Beehive Tech and Entrepreneurship Center in South Central LA provides after-school programming focused on 21st century industries like games, music production, and digital design for students from South Central LA. The basic idea was that the IYA would partner with SOLA and Hamad Aerospace to develop challenge-based training for high school students in material sciences and engineering. For 4 months, 15 of our undergraduate and graduate students worked with 3 of our faculty as well as instructors and students from SOLA and advisors from Hamad Aerospace on the development of this program. Since this work is ongoing and still has not been shared publicly, and since this presentation is being recorded for the IYA website, I will stop this presentation here. However, I did present briefly at the MDI workshop the amazing findings of this group of students, faculty, and community partners. And I got very enthusiastic feedback from the workshop participants. So please come back and learn more about the project and the IYA and SOLA partnership in a few months. Overall, if you want to learn more about the IYA and the CBRL, please visit our website shown here on this slide. Thank you for listening.